Okay, this is Dylan Sieverts on January 27th. Going over quiz number 2 for kinematics, chapter 12. So basically it's saying a car stops over a distance of 41.5 meters. So I drew my diagram here with a velocity of 22, from a velocity of 22.4 meters per second. Calculate the car's braking distance from that velocity when it is going up a 5-degree incline. And it says you must use F equals ma. So with that process, I basically just drew my basic free body diagram here. I drew the picture, then I made it into a free body diagram, and then I set my x and y axis along the incline. However, I wanted to figure out the coefficient of kinetic friction since the car is moving in relation to it being flat, because that would give us the most knowns. So I did my sum of forces in the x direction, which is basically going to be the force of friction, which is opposite to the force of the car going in the other direction, which is its acceleration times mass. So I substituted that in, and I know that A, the acceleration, is the coefficient of static friction times gravity. And from my basic kinematic equations, I listed all of my knowns, my final velocity, my initial velocity, and my distance, which this is distance. Sometimes kinematic equations use x or d or s or whatever. And so then I plugged everything in to solve for the coefficient of static friction, and got that, which seemed pretty reasonable. I feel like it's a little bit higher than normal, but I hope that it's correct. I know that usually in homework and such, it's like 0.2 to 0.4 or something, for like realistic purposes. So it somewhat passes the coherent check. And so then I still need to find what the problem asks for, which is the distance it takes for the car to stop when it's going that fast, when going up a 5-degree incline. So I did my sum of forces in the x direction, because we don't really care about the y at this point. We have enough knowns since we solved for the coefficient of kinetic friction. So F equals ma. I know that my force is the sum of forces in the x direction, so that's there. And then I set that equal to F equals ma. The masses cancel, and it can pull gravity out, solve for everything inside, and plug in my coefficient of static friction I found earlier, and solve for the acceleration. From there, I use my original kinematic equation that I had. The only thing we are looking for is the distance it takes for the car to stop. Solve for d distance, and that is it. I hope that I understood the problem correctly, because I don't fully understand the second sentence, how it stops over a distance of 41.5 meters. If 22.4 was supposed to be our initial velocity, or yeah, but that is it for quiz number 2.